Okay, so back to the VCAA 2021 physics exam section A and up to question 6. All right, so a magnet approaches a coil with 6 turns. As shown, during the time interval delta t, the magnetic flux changes and the average EMF produced is 1.2. Okay, so you need to know what the formula is, and it is on the formula sheet, and it is that the average EMF, oops, I haven't done that quite right, but anyway, would be negative N change in flux with time. Now, in this case, the negative just indicates that it opposes. In this case, we don't really need to worry about the negative, because that just tells us like the direction of the induced current, that it's opposite to the change in the, the EMF is opposite to the change in flux. So we just put in the 1.2, because that's the average EMF. The number of turns is 6. The change in flux, we're told, is 0.05. And the change in the time. So the change in the time then would be 6 lots of 0.05 divided by 1.2. And I have, yep, they're all standard units. I didn't check that, but they are all standard units, so there's no conversions going on. And when you do that, you find that becomes 0.25, and so closest to 0.25 seconds that change is occurring over. All right, next question, question 7. Question 7. Let me scroll down to the next page. There it is. Mobile phone charger uses a step-down transformer, 240 volts AC to a voltage of 5. Phone draws a current of 3 amps while charging. Assume the transformer is ideal and all readings are RMS. Which one of the following is closest to the current drawn from the mains? Okay, so again, you need to know from the formula sheet, V1 on, get rid of that, V1 on V2, and then we're looking at current, so current 2 over current 1. So it goes 240 to 5 volts. The current mobile phone draws the current. All right. So the mobile phone is what the voltage, 5 volts, is going into over current 1. And so then the current that we're after, 5 on 240, if we turn over both sides, and so the current is 3, 5, 15 over 240, and when you figure that out with your calculator, 0.0625 amps. D is the closest to that. All right, question 8. The diagram below shows a simple electrical generator consisting of a rotating loop in a magnetic field connected to an external circuit with a light globe. The split ring commutator and brushes. A split ring commutator and brushes. The direction of rotating is shown. All right, so which of the following best describes the function of the split ring commutator? All right, so all we're interested in is the split ring commutator. There it is there in the diagram, and what its purpose is. All right, so the fundamental purpose of a split ring commutator is, so split ring commutator in a generator, which is what this is to give DC output. Okay, so that's the fundamental purpose. So all the question asks us is about that. So what we're looking for is something that says delivering DC. We want DC output. And so when we look at our different alternatives, A, it delivers a DC current to the light globe. Bingo. All right, that's the purpose of it. There it is, say there. B, it says about an AC. C is now talking about forces on the loop. So is D talking about forces on the loop. But the question doesn't ask us about forces, it asks us about the function of the split ring commutator. Right, and in a generator, give us a DC output. So the only one of those here that's got anything to do with a DC output is A. All right, the next question, or the next two questions, in fact, 9 and 10 relate to this information. So Lucy is running horizontally, speed of 6 meters per second. It is platformed vertically above the water, 8 meters. Lucy runs off the end of the platform and reaches the water after a certain time. She lands feet first a certain distance away. All right. Which of the following expressions correctly gives the distance D? All right, so now what we're going to do is think about horizontal here, because D is the horizontal distance. So horizontally, what do we know? We know that the acceleration is equal to 0, that U equals V equals 6, and speed is distance over time, if you like. So 6 is the distance over the time. So the distance then would be 6t, which is alternative B. All right, so that's all that is talking about. Okay, which of the following is the closest to the time taken for Lucy to reach the water below? All right, so now what we can do is we can now look vertically. Because we're now reaching the water. And what we know is that the acceleration is 9.8. We know that the distance that she has got to go is 8. We know that initially she's running horizontally, so the initial vertical component of her speed is 0, and we want to know the time. So if we use x equals ut plus a half at squared, and put our numbers in, plus a half times 9.8 times t squared, and then 8 would be 4.9 t squared, and t squared would be 1.632 when you work that out with your calculator, which then leads to t being the square root or at 1.277. So we need to have a look and see which one of these alternatives here is closest to 1.277, and alternative C. All right, so there's questions 6 to 10. We'll leave that for this video, and more videos for the next group of questions.